Alright, Algebra 2, here we go. We're moving on to section 3.2. Okay, solving systems of equations algebraically. Okay, today we're going to look at solving by substitution. That's our essential question, how to use substitution to solve for a system. Remember, a system of equations is two or more equations, when you have two unknowns. If you have two unknowns like x and y, to solve for them, you have to have at least two equations to find it. A lot of times we call this simultaneous equations because we're looking for that x and y value where we solve both of them at the same time. Okay, we talked about that with graphing where we tried to find where the lines intersected. Okay, how do you do it with substitution? First thing we do is we use it when one or both of the equations is x equal or y equals. Okay, that way we can substitute in, which is what you do in the second step. Okay, you think about substitution. If you're an athlete, you're taking somebody off the field and hopefully putting somebody of equal talent back onto the field to take their place. It's kind of like what we do here. If one of our equations is y equals 2x plus 3, then we're going to take that 2x plus 3 and we're going to substitute it in for the y in the other equation. And then that's going to give us an equation with one variable which we can solve because we've been doing that in that step 3. Go ahead and solve for it. And then you can plug that solution in for that variable into the other equation and solve for y once you know that. Let me show you how it goes. It looks like this. Here's our system of equations. We have two equations, 3x plus 4y equals 12, and we have y equals negative 2x plus 10. As long as one of the equations is y equals or x equals, we'll use substitution. If it doesn't, you can still use substitution, but it's probably easier to use it algebraically. I'm going to show you that next. So what do we do here? Okay, what you're going to do is, if this is equal to y, then we're going to substitute that in to that y right there. So what does it look like? Taking that first equation, instead of 4 times y, it's now 4 times negative 2x plus 10, and that equals to 12. There's our substitution right there. That was y, they're equal, so I plugged it in for the y in the first equation. Now I'm x all the way across. This I can solve. Do my distributive property. I'm going to get a minus right here. Positive 4 times a minus 2 is negative 8x. 4 times 10 is 40. Equals 12. Combine like terms here, that's negative 5x. Subtract the 40 over. So I get 5x is equal to, what do I get there, negative 28? Okay, does that look right? Positive 40, we subtract it over. Then divide out your negative 5. Okay? Something still doesn't look right about that though, does it? But that's what we got. So we get that fraction right there. X is equal to 5 goes into their negative and a negative, so it's positive 5 and 3/5, which for a lot of you guys is probably going to be 5.6 because you'll use the decimal value there. Okay. Once you know your x, I can plug it back into here to find my y. Negative 2 times 5.6 plus 10. That's negative 11.2 plus 10. I get negative 1.2. So my point then for x, y, and I write it as a ordered pair because if I graph these two lines, which we could have, we could put that into y equals and graph them both. That's where they would intersect. Doesn't matter which method you use, you get the same answer either way. Okay? So that's how you do it with substitution. As long as one of them says x equals or y equals, plug it into the other one and solve it. And then go back and find the other variable. Okay? The other method is elimination. Okay? What we try to do here is we get them both in, as you can see here, in standard form with our x's and y's in the same column. And what we look for is if I add straight down, will one of them cancel? Will the x's or the y's cancel? Occasionally they'll both cancel, and that's okay. If the variable doesn't cancel, then we're going to multiply one of the equations or both of the equations to make x or y the same but opposite sign. Like we might have a 5x and a negative 5x, or a minus 12y and a positive 12y. Whatever it is. So that when we add down, one of them cancels out. And then you solve for that variable, and then plug it back into one of the equations and find the other. So when I look at this problem right here, 4x plus 2y equals 9, and negative 4x plus 3y equals 16. When I look down and I add them up, I see that my x's cancel. I have 0 x's, so they're gone. So I get 5y equals 25. Divide out the 5. Y is 5. Then I can take that y is 5. I can plug it back into either equation. I chose the first one. There's my 2 times y, my 2 times 5. That's 10. Subtract it over. 4x is equal to negative 1. Divide it out. X is negative 4. And again, I write my answer. You can kind of see it here. I'm getting a little out of the way here. Negative 1/4, 5. Okay? And again, I write it like an ordered pair because if I graph both these two, that's where they would intersect. Okay? Let's take a look at another one. 2x plus 7y equals 4, and 3x plus 5y equals 5, or negative 5. When I look down the columns, neither of them cancel out. I don't get a 0x or a 0y. And I'm not going to use substitution here because I don't have an x equal or a y equal. So what I'm going to do, and this is your choice, okay? I'm going to look to multiply one or both equations. Like if I could multiply this to equal that, I would multiply it. But I can't get them both. I can't do that. So what I see though is that 2 and 3 both go into 6. And if I wanted to use these two, I could have, but I like smaller numbers, so I'm going to do it this way. If I multiply this by 3 and this by negative 2, the whole equations, what do I get? Well, I come down here, I'm going to get, when I distribute all the way across, I'm going to get 6x plus 21y equals 12. Same equation is up there, it just looks different, same values. Negative 2 times all of these, I get negative 6x. You can see what I just did right there. Minus 10y equals positive 10. Now I can take these two equations and do what I did in the last one. I add them up, that cancels out. I get 11y equals 22. I'm good to go. I divide out my 11. I get y equal to 2. Okay? Take it, plug it back into either equation. It doesn't matter. I'll take the first one. 2x plus 7 times 2 equals 4. 2x plus 14 is equal to 4. Subtract the 14. I get 2x equal to negative 10. X equal to negative 5. What's my answer? Negative 5, 2. If I'd graphed them, you guess it, that's where they'll intersect. Okay? There's another example or two in the book that you can look at. We're going to spend at least a day or two solving these. Then we'll look at some application of it. And we'll move on from there. But make sure you get these notes down. Maybe go back and look through it again to if you're a little fuzzy on it. But I know this gives us a little problem at first, but realizing the little trick of how you would multiply or what you would multiply by to get their x's or y's the same, but one with an opposite sign, so when you add them up they cancel out. We'll go over all that in class. You get plenty of examples there to take a look at it. 2 algebraic methods to solve systems of equations: substitution and elimination, along with our graphing. That's 3 ways of solving these. Doesn't matter which way you solve them, you get the same answer every time for any particular problem. Okay, we'll see you in class, and we'll look at this a lot more. All right, have a good one.